In my last video about Mexican Coke, I made an incredibly bold claim. Mexican Coke is a lie. This bottle that I tested at the beginning of the video contained, from what I can tell, 0 sucrose in it. And that led me here, and I discovered something that Coke is doing that they haven't told anyone. This is the American Coke?
Correct.
Okay. That's not what I expected to see. Coke is not telling anyone about this. They're keeping it as secret as the federal government will let them.
It doesn't even say anywhere. It says,
In my first video, I tested Mexican Coke with a blood glucose meter and a more than century-old chemical reaction. And based on those results, I claimed that Mexican Coke has no actual sucrose, also known as sugar, in the bottle, despite saying cane sugar right here on the label. That was an aggressive claim, especially because I never actually measured the sucrose. I only measured glucose. So, 2 chemistry professors decided to call me on it. This is Jeb and John. They're both professors at Shippensburg University, and what they did is they hired an undergrad, this is Rebecca, to attempt to replicate my results. She used this machine. It's a high-performance liquid chromatograph. Everyone in chemistry just calls it an HPLC. Rebecca bought several samples each of Mexican and American Coke. She sonicated them to get rid of all the carbonation, and then she filtered them, and then she ran them on the HPLC. The data this machine spits out looks like this. It's called a chromatogram. The x-axis is time, and the y-axis is millivolts, but you can just think of it as concentration. Now, each of these peaks that you're seeing represents a single chemical. And you know which peak is which because before you ran your actual samples, you ran pure compounds, and you saw how long each of those took to elute. Elute. That's a good word. And the area under each peak is proportional to the amount of each of those chemicals.
With the same amount of sucrose, glucose, and fructose, the sucrose peak would be visibly larger than a glucose peak, and the glucose peak would be visibly larger than the fructose peak.
Now, in my creepy basement, the best I could do was to sort of semi-quantitatively measure only glucose. But this HPLC can measure all 3 sugars at the same time with much higher precision and accuracy. Now, look at these 2 chromatograms. One of them is American Coke, and the other is Mexican Coke. And if you want to pause the video here and guess which is which, please do that right now, because I'm about to tell you that the one with the larger fructose peak is the American Coke, which makes sense because it's sweetened with high fructose corn syrup. In other words, corn syrup that has more fructose than glucose, so you would expect a larger fructose peak. Black line is Mexican Coke, and pink line is American Coke.
Yes.
Nailed it. Now, this is the Mexican Coke, and as you can see, the fructose and glucose peaks are basically equal in size, more or less, because all the sugar in the Mexican Coke started out as sucrose, which is 1 unit of glucose bonded to 1 unit of fructose, so you get equal amounts of fructose and glucose. The bottles of Mexican Coke that Rebecca tested had on average 2.8 grams per liter of sucrose left in them. So in these bottles of Mexican Coke, 97% of the cane sugar had been destroyed by the acid. In other words, in my first video, I was 97% right, which I'll take. I'll take that. The next interesting question is, how long does it take for 97% of the sucrose to disappear? And does that mean that any bottle of Mexican Coke you buy will have no sucrose in it? Now, to really answer this question, you need a bottle of Mexican Coke in which the reaction hasn't started yet. You need freshly bottled Mexican Coke. That's a problem because if Mexican Coke really and truly is made in Mexico, then it would take at least a few days to get up here to Pennsylvania, by which time it might be too late to get the measurements you need. So the team found a local soda company, Reading Soda Works, that was about an hour away, and they bought a bottle of freshly bottled sarsaparilla soda that was sweetened with cane sugar, and they ran it on the HPLC. And they were doing this as a baseline, basically to figure out how much sucrose had been hydrolyzed. And they found that basically none of it had. None of it. So they tested the pH of the sarsaparilla soda, and they found that it was about 4.6. That is 1.85 units higher than Mexican Coke, which is way down at 2.75. So that means that Mexican Coke has almost 100 times more acid than the sarsaparilla soda. Hang on. Is that right? I think that's right, because you do 10 to the 4.6, or 10 to the minus 4.6. Or something. Sorry, 71 times more acid than the sarsaparilla soda. Okay, it's not 100. So then the team did something that I think is super clever. They took the sarsaparilla soda and they added hydrochloric acid to it to get it down to a pH of 2.75. In other words, matching the pH of the Mexican Coke. And then they split it up into 3 batches, and they stored it at 3 different temperatures. 3 Celsius, which is about the temperature of your fridge, 22 Celsius, which is roughly room temperature, and 39 Celsius, the temperature of a hot summer day. And they followed all 3 batches for 3 weeks. And after just 14 days at 39 Celsius, all the sucrose was gone. All of it. Even at room temperature, after just 3 weeks, that's an additional 1 week, almost half the sucrose had hydrolyzed. This is not the shocking thing that Coke is doing, but it did make me wonder. If the Mexican Coke you buy at the store contains a 50-50 mixture of fructose and glucose, and the American Coke you buy at the store contains those same 2 sugars but in a slightly different proportion, 55% and 42%, is this very subtle difference really what people are tasting when they distinguish between American and Mexican Coke? This was a big question in my first video. Now, I had a hunch that the answer was no, so I brought a sample of pure high fructose corn syrup to Jeb and John's lab, and we ran it. Look at this chromatogram. All right, so these are the fructose and glucose peaks. They are as you'd expect. The fructose peak is higher. And this right here is a little tiny sucrose peak. But what is this? This small peak at 5.825 minutes. Now, as soon as we saw this, we went back and looked carefully at the chromatograms of Mexican Coke and American Coke, and we confirmed that, yeah, this tiny little peak is present in American Coke, but not in Mexican Coke. So my interpretation of this is that there is something, probably a sugar, in American Coke that is not present in Mexican Coke.
Yeah. Yeah. Now the amount isn't large.
Right. It's small.
But it's detectable.
But like
it's detectable.
This is at a concentration that is well above taste thresholds. Like
probably.
Depending on what this is and what the actual taste threshold.
Right.
You could probably taste this.
Possibly.
Back in 2014, during the initial Mexican Coke wars, a group of scientists from the International Society of Beverage Technologists published this paper. Now, this paper contains a chromatogram of a soft drink sweetened with high fructose corn syrup, and there are actually multiple peaks that come off before the glucose, which they identify as maltose, maltotriose, and maltotetraose. Now, those are fancy names. All they are is 2, 3, and 4 glucose subunits joined together, respectively. Now, it's possible that this peak right here that we found in our high fructose corn syrup is maltose, or maltotetraose, or even a mixture of all of these glucose oligomers, or some other higher order sugar. In my last video about Coke, I glibly dismissed the idea that anyone could taste the difference between sugars. But what about everybody who claims they can specifically taste the difference between cane sugar and high fructose corn syrup in a soda? Those people are just wrong. Yeah, turns out I might be wrong. Yeah, here's the deal. We are going to run a taste test in this video that will help answer that question. A taste test that it would not have been possible for anyone to run before now. The night before we got to Shippensburg, Jeb found this bottle in a store in Mechanicsburg, Pennsylvania. This is a holiday edition American Coke, except it's made with cane sugar. This is the Holy Grail. It's the thing that started the Coke Wars. It's American Coke with cane sugar and no other differences. It's not Mexican Coke with this double the sodium and who knows whatever else. Obviously, Jeb bought a couple bottles and we immediately threw it on the HPLC. Now, we were all expecting to see basically the same chromatogram as Mexican Coke. Complete inversion, complete hydrolysis of the sucrose. But that is not what we saw. Look at this massive sucrose peak. There is still roughly 64 grams per liter of the original cane sugar left in this bottle.
And so now we have to rewrite this whole video.
From a sugar standpoint, this Coke is nothing like Mexican Coke.
So either this is not very old or it was kept at a very cold temperature.
Yeah.
I can actually do the math if you want me to.
Yeah, let's do the math.
So I'll be back.
Okay.
Yeah, I'll be back. Yeah.
That's the best kind of math when somebody else does it for you.
What I get based off the idea that it was stored at room temperature the whole entire time
Yeah.
was that it was only about 21 days ago.
they could market this as different. Yeah. Because if I would have consumed this versus a regular American Coke, I would have had a different sugar, like, profile experience in my, you know what I mean?
Coke did something very special here. They gave us a soda that has the low pH that we've come to expect from Coke, gives us the bite and the burn, but it also has most of the intact cane sugar left in the bottle. It's mostly a cane sugar soda. Coke has not done this before. This is an achievement. And who did they tell about this achievement? No one! They didn't tell anyone! It doesn't even say anywhere. It says, you have to look to find that it's cane sugar. That's fine. Look, nowhere on this bottle does it say cane sugar or real sugar or any of the other marketing terms that other companies fall all over themselves to tell you. The only place on the entire packaging where you will see cane sugar is in the ingredients label, which Coke is required by law to disclose. This is the Coke that allows us to run a taste test that we have never been able to run before, which is American Coke with cane sugar versus American Coke with high fructose corn syrup. Can people taste the difference? At the same time, I was also struggling to figure out, what is Coke up to here? Have they lost their minds? Do they know something we don't know? I don't know anything about marketing, economics, companies, or really capitalism. So I found some people who know more about economics than I do. Let's go. I broke into NPR headquarters and tracked down two of the hosts of Planet Money. Could I have you guys close your eyes?
Sure.
We did some taste tests. Taste all three.
Okay.
Think about whether or not one of them is different from the other two, and if so, which one?
Okay. I think number 3 is different. Vote locked.
It's maybe a little less sweet.
I
number
agree.
3. No, maybe
Before
one.
this,
One.
George.
I think one is less.
Oh my god.
Or maybe 1 and 2 are less sweet, and 3 is sweeter.
So
Wow.
okay, 3 is sweeter.
Jeff's now named all of them.
And they disabused me of some of my conspiratorial thinking.
What better marketing than the President of the United States saying, go buy some cane sugar Coke?
Yeah. And that feels a lot less conspiracy theory and more like what a company would try and do if they were on their game.
A rapacious profit-maximizing company that wants to sell as much sugar water as possible.
Yes, exactly.
U.S. cane sugar prices are just artificially high. You could always count on cane sugar being more expensive to some degree. And so high fructose corn syrup could sort of always sneak in under.
The amount of sugar in a can of Coke,
Yeah.
if it's high fructose corn syrup, it costs wholesale maybe 4 cents. You're looking at 4 cents of sugar.
Wow, okay, that's lower than I expected. Oh
in a
my
can.
gosh. Yeah.
And if that were cane sugar
Yeah.
at the current spot price, that would be 4.7 cents. And then multiplied by however many bajillion cans that Coke sells.
Yeah,
It makes a difference.
Yeah. And then I wanted to see if they could taste the difference between cane sugar and high fructose corn syrup in American Coke. So now we are tasting Coca-Cola products.
I think they're all the same, George.
Number 1 is sweeter to me.
Okay. Well, okay. He had a 1 in 3 chance of getting it right.
No, you have to test Kenny again right now and see if he can replicate.
Okay. Absolutely not. I refuse.
So we tested Kenny again.
Oh no, I think this was the cane sugar.
Nailed it. You're right.
What?
You nailed it.
Kenny, are you a super taster?
Maybe.
And we tested Kenny again.
I think it's this one.
So you're actually wrong. It was the middle one.
No.
Yeah.
I'm not a super...
No.
I know.
That was a fluke.
I don't think so. I think it's really hard to tell the difference.
And yes, obviously Jeff and Kenny are very far from making a statistically significant sample, but this is what I think of these very limited results. Jeff and I got it wrong. I think the one to my furthest left is cane sugar and the other two are high fructose corn syrup.
No.
Kenny tried it 3 times and got it right twice.
Should I quit this job and go become a sommelier?
So maybe there are some people whose taste buds really can detect this difference. And maybe all of them commented on my last video.